Hello everyone, and welcome to my series, Intro to Computer Networking. My name is David Young, and I'm a computer science student at Concordia University, Chicago. And in this series, we're just going to be covering some of the absolute basics and fundamentals of computer networking. So if you're brand new to this topic, or you just want to brush up on some of your definitions and your fundamentals, this is the place for you. So without further ado, let's begin. So this video is going to serve as sort of an overview of the course, as well as a 30,000 foot, view of what computer networking is and what the internet is. And in the next video, we're going to move on to network components, what makes up the network's hardware, and then in the third video, we're going to move over to a more software or idea-based side of protocols and communication. After that, we're going to move on to network performance and how the internet maintains a stable connection for all of its users. And then finally, we're going to cover network security and how do we keep the internet safe and your data safe when you're using it. So what is the internet? It's kind of a nebulous question, and when people talk about it a lot, I think that they don't always understand it precisely. And there are a lot of ways that we could define this. But what I'm going to go with is this definition. It's the infrastructure and rules that link computing devices together across the globe. That's at the base of what computer networking is. We need infrastructure and we need rules in order to make computer networks function and connect devices in the way that we want them to. A good analogy for this is the roadway system that we have across the globe. So this is just a picture of the US roadway system. The roadway system consists of infrastructure. There's the pavement that you actually drive your car on. But there's also rules. You can't, for instance, hop over a curb or cross a double yellow line or blow through a red light. And so that infrastructure in connection with those rules provide us a network that can take us from point A to point B and keep us all connected. And so that roadway analogy is something we're going to be returning to throughout this series in order to sort of elucidate what networking is in a way that's more accessible to many of us. So what might we connect to the internet? We've talked about how we're connecting devices, but what are devices that we would connect? Well, the first and most obvious is going to be your computer. You're connected to the internet right now because you're watching this video. And computers are the basis of the internet and the reason the internet exists, because we wanted to connect computers together in a meaningful way. Phones also are an obvious choice. They are computers in your pocket, and so your phone is connected to the internet, but it's not connected in quite the same way. And we're going to talk about that as we get into the infrastructure of the internet. Video games are also connected to the internet. Video game consoles are connected so that you can connect with people across the world and play games together. And more recently, we're seeing vehicles even connected to the internet. We'll talk about more examples of things that are connected to the internet later. And there's been a revolution in what we do connect to the internet. It's frequently cited as the Internet of Things. It's a connection of devices that ordinarily were standalone into the broader internet to improve functionality. And we're seeing that now with cars and Tesla's initiative and these other electric car companies to create a self-driving car. But if we think of the internet's purpose, which is to connect computing devices together across the globe, we're going to run into a problem pretty quickly. Let's let n in this example equal the number of devices. Right here it's 9. And we want to connect all of these devices to one another. So let's start at our top device and work our way around. Well, from our top device, we're going to have to make 8 other connections. Now, maybe you can already see a problem with this. If these computers are far apart geographically or in remote locations, it's going to be really difficult to collaborate and then to build the infrastructure to connect all of these computers. And then as we move on, we need to still connect all of the rest of the computers. And so our second computer needs 7 additional connections. And so what's going to happen as we increase the number of computers that we're connecting is that the number of connections is going to increase with a complexity of n squared. We call it this, it's a big O of n squared. And so this is simply infeasible, not just because of geographic reasons, but because of sheer volume. And so we need a better way. So what the designers of the internet thought is, what if we can manage these connections through hubs? And so every computer is connected to a hub, and that hub manages its connections to the other computers in its network and the other computers around the globe. And so we see here the first step of this process. Each computer, instead of connecting to all of the other computers, has one connection, and it connects to these hubs that we have here. And these hubs are going to manage the connections so that the computers can talk to one another. And then we're going to see that the hubs end up connected to each other. So now there's a direct line from every computer to every other computer. But it's managed in a way that's going to result in a lot less infrastructure. This is 12 connections here. And that's much more maintainable. There's fewer connections, but it's also scalable too. When you add a new device, you don't need to connect it to the billions of other devices that already exist. You simply need to connect it to a hub, and through that, you're connected into the entire global internet. And so we refer to the internet for this reason as a network of networks. The internet is not essentially a united entity, but it's a collection of entities. And so we see down here, a home network is an example of a network. This is similar to the hubs that we've talked about before. This is representative of that hub. We call it a router. And this router connects to the computer. It connects to this Wi-Fi antenna, which in turn wirelessly connects the rest of these devices. So all of these devices are connected through this hub. In a similar way down here in this network, all of these devices are connected together. And then each of these networks is connected into this larger network. And so the internet is not actually one conglomerated thing, but it's a result of the collaboration of several different networks, of several different infrastructures. And through that collaboration, we connect everyone. One way to think of this, as I mentioned earlier, is our roadway system. Our roadway system has a lot of different networks. We might have the network of roads. If I'm going to my friend's house and he lives the next street over, I can use the network of roads that exists around me within my city to drive there. I just drive on Surface Street, down Main Street to get where I need to go. But sometimes my friend won't live in my city, and so I might need to get on the highway and go to the next city. And sometimes my friend might not even live in the same state as me, and so I have to get on the interstate. And so we see these various networks emerge, these local networks that connect houses and city infrastructure, connected to highways, which connect cities into states, and then those highways are connected in turn to interstates, which connect to country. And so you can see how there's these tiers of networks emerging. This is a similar way to the structure of the internet, and so if it helps, you can think about it like that. There are various levels at which we can enter the internet and in which data moves around the internet. In our next video, we're going to talk about network components. Thank you for tuning in to today's video. If you have any questions, I would love to answer them. Please leave them in the comments and I'll do my best to respond in a timely manner. Thank you so much. I'll see you in the next video.